Different types of relay. Depending on the operating principle and structural features, relays are of different types, such as electromagnetic relays, thermal relays, power-varied relays, multi-dimensional relays, and so on, with varied ratings, size, and applications. This video main aim is to give a brief idea about various relays that are employed for a wide variety of control application. Some of these relays are described this video. Electromagnetic relays. These relays are constructed with electrical, mechanical, and magnetic components and have operating coil and mechanical contacts. Therefore, when the coil gets activated by a supply system, these mechanical contacts get opened or closed. DC and AC relays. Both AC and DC relays work on the same principle as electromagnetic induction, but the construction is somewhat differentiated and also depends on the application for which these relays are selected. DC relays are employed with a free-wheeling diode to de-energize the coil, and the AC relays uses laminated cores to prevent eddy current losses. Attraction-type electromagnetic relays. These relays can work with both AC and DC supply with attract a metal bar or a piece of metal when power is supplied to the coil. This can be a plunger being drawn towards the solenoid or an armature being attracted towards the poles of an electromagnet as shown in the figure. These relays don't have any time delays, so these are used for instantaneous operation. Induction-type relays. These are used as protective relays in AC system alone and are usable with DC system. The actuating force for contacts movement is developed by a moving conductor that may be a disc or a cup through the interaction of electromagnetic fluxes due to fault currents. These are of several types like shaded pole, watt-hour, and induction cup structures and are mostly used as directional relays in power system protection and also for high-speed switching operation applications. Magnetic latching relays. These relays use permanent magnet or parts with a high remittance to remain the armature at the same point as the coil is electrified when the coil power source is taken away. Solid-state relays. Solid-state relays uses state components to perform the switching operation without moving any part. Since the control energy required is much lower compared with the output power to be controlled by this relay, that results the power gain higher when compared to the electromagnetic relays. These are of different types. Reed relay, coupled SSR, transformer coupled SSR, photo-coupled SSR, and so on. Hybrid relays. These relays are composed of electromagnetic relays and electronic components. Usually, the input part contains the electronic circuitry and performs rectification and the other control function, and the output part includes electromagnetic relay. Thermal relay. These relays are based on the effects of heat, which means the rise in the ambient temperature from the limit directs the contacts to switch from one position to other. These are mainly used in motor protection and consists of biometallic elements like temperature sensors as well as control elements. Thermal overload relays are the best examples of these relays. Reed relays. Reed relays consist of a pair of magnetic strips, also called as reed, that is sealed within a glass tube. This reed acts as both armature and a contact blade. The magnetic field applied to the coil is wrapped around this tube that makes these reeds move so that switching operation is performed. Relays are also available with different pin configurations like 3-pin, 4-pin, and 5 relays. The ways in which these relays are operated is shown in the below figure. Switching contacts can be SPST, SPDT, DPST, and DPDT types. Some of the relays are normally open, NO type, the other are normally closed, NC type. Dear sir, Thanks for watching my videos. If you have any question, write in it comment box. Don't forget to like and share. For more updates, please subscribe to our channel Learning Engineering and get the notification to press the bell icon.